Welcome to Velasco's Lab at Home, where love and science prospers!
Before today's experiment, let us introduce ourselves first. I am Jomel Velasco, the pillar of the home. When I was in high school, limited experiments are done in the school lab. Now, here in our video, we will show you how you can find science-tacular experiment in the comfort of your home.
I'm light of the house, Miss Roma Velasco. I got $2 and 1 cent. In the school laboratory, we started to finish our experiments, Daddy says.
And me, I am Cristel Velasco, grade 12 STEM student of UE Caloocan. I love colorful and sweet things. That is why we came up to the idea of making this experiment. You're making rainbow at home. And this is your
Rainbow in Glass!
That we know this experiment, let us have a brief explanation of what are the things we expect and what are the things we are going to learn. First, we know that some of you are bored at home. So we want to make your day amazing and fun with great things to learn. Some of you might heard the word dense in your daily conversation, but what is density? What is dense when science intervenes? In this experiment, we should know what density is. By using different amount of sugar and food colors stirred in hot water, we would be able to make rainbow that can be placed inside our home. With varying amounts of sugar in a constant amount of water, we'll be able to know if more sugar would lead to less dense or denser. Next is we would know if we are able to create a beautiful scenery inside a glass by just using warm water and sugar, two of our basic necessities at home. Lastly, we would be able to answer the question, what happens if something is denser?
Before proceeding experimenting, we should first observe safety protocols.
Always remember that safety first.
First, we need to make sure that our workplace is clean. No sharp objects or slippery places to avoid any hazards at home.
Mental hairnet, so that your hair wouldn't get damaged and you'll be comfortable.
Then next, wear your safety goggles to protect your eyes in the possible hazard in the area.
Wear your gloves and ready. Wear your gloves tight and be ready to fight in the experiment. Don't forget your lab gown. If you don't have any at home, just be sure to improvise some so you wouldn't get any hazards or any accidents that might occur in your home.
Remember that while we do the experiment, it is okay to move your surely and carefully.
It's a must. Note, you must first have first aid kit.
Now, for the most awaited part, we will now start making a rainbow. First, we must identify the materials we are going to use. We have here our glasses, 6 glasses that will be used in different colors, and 1 glass to be used in the final output or the rainbow. Next is the chopsticks to be used in stirring sugar, food color, and the warm water. Next is the 1/2 kilogram of sugar. It is the most important material in our experiment. Next are the food coloring, labeling red, orange, yellow, green, blue, and violet. Lastly, the 1 liter of hot water. And also, we have measurement for the measuring tools and the measuring spoons.
We must line the plastic cups straightly for it to be in order. Next is we need to put the label so that we can identify the color for each number. Using the measuring cup, measure an amount of water and remember it. Then put it in the first cup. With the exact same amount of water, fill in the remaining cups. Always remember that it should be exact. because it is a constant variable to put the exact amount of water for each cup. Now get your measuring spoon. We will put the amount of sugar in the table you see in your screen for each color. After putting the sugar for each color, stir it carefully in the hot water. So you can see the number of sugar you put it in this glass, it increases because it is our independent variable. Stir it carefully in the hot water. Be sure that the sugar will be dissolved. That's why we use warm water, so that we are sure that the sugar will be dissolved. Remember that stirring and temperature affects the solution. Use a separate chopstick to stir each cup and stir until the sugar is completely dissolved. It's crucial that all of the sugar be dissolved in each cup. Use separate spoons so you don't dilute one density with another. Now, get your dropper and put it in the glass. But you can see in the video that the first attempt is not quite successful. But in the split screen, you can see that in a small elongated tube, the density of each solution is visible. You can see different colors lining up.
Before we end, we must of course clean the workplace. Dispose the chopstick and the gloves properly in the trash can.
Now, we're good to go back in our home.
Now that we are done with our experiment, we will now proceed to the results, discussions, and conclusion. As we have seen in the video, the experiment is not quite successful. The solutions in the glass quite stirred and mixed, so we didn't see the density. So we come up with the idea of putting it in a small cylinder, which you see also in the video, so that we can see the density and the goal of this experiment. So once again, the rainbow in glass. So here in our density. First, what is density? Density is a measure of mass per unit of volume. Based on the experiment, we have learned that if an object is more dense than water, it sinks. So it goes down. If an object is less dense than water, it floats. It goes up. So here in our experiment, we would identify the independent, dependent, and constant variables. The independent variable is the amount of sugar. As we know, we didn't have the constant amount of sugar per color. Next, the dependent variable. It is the ranking of the density. You can see the ranking of the density there because you know if it floats or it sinks. Next, the constant variable. It is the amount of water. We ensured that the amount of water is in constant amount because if it isn't constant, we wouldn't get the experiment right. As you can see in the graph, in the x-axis, the amount of sugar or the dependent variable is listed. It is placed in the half, the red color is placed in the half, and it is ranked first. The second color, which is orange, with amount of sugar, that is 1 tablespoon. Next is the yellow, 1 and 1/2 tablespoon of sugar. Next is the green, with a 2 tablespoon of sugar. Next is the red, with a 2.5 tablespoon of sugar. And last, the violet, with the amount of 3 tablespoons per sugar. Note that the increasing ranking means more dense. So, what we hear a while ago, more dense leads to sinking. So the next one is, as the experiment is progressing, you won't see the color you're adding right away, so maybe it would mix and test. Just keep carefully stirring the sugar water solution into its layer, and you'll see it will begin to stack up. As we all know, density is the measurement of how much an object is packed into a measured space. That's how we get the equation for density. Density is equal to mass of the object, solution, or matter, divided by volume, the measured space. Nearly every substance and material imaginable has a different density. This is especially true for the sugar solutions we made. Discussion. Conducting the experiment, we knew that by increasing the amount of sugar in solution, but keeping the amount of water constant, we created solutions that have increasing densities. So it has a direct proportion. As you add sugar to the water, more and more sugar molecules take the available space between water molecules, making the solution denser. The cup containing 3 spoonfuls of sugar will be the densest, and the cup with 2 tablespoons will be the least dense. As you can see, a solution with lower density stack up after mixtures with higher density. When we dissolve sugar in water, there's a point in which no more sugar can dissolve. Next, lastly, the conclusion. With the experiment, we can therefore conclude that when you add sugar to a liquid, it causes the solution to become more dense. The more sugar you add, the more dense the solution is. The denser the solution is, the more it will sink. So here's the picture of the different colors of the rainbow. And the next picture is the successful experiment where you can see the red at the top, the orange, the yellow, the green, the blue, and lastly, the violet. Here are the references used in conducting the experiment. Thank you, and we hope that we can have your quarantine be more fun and science